Hi class, it's Mrs. Kane. I'm back for your second day of e-learning. Thanks to those of you that completed that first worksheet. It gave me some good insight into some of the mistakes that were made and some things that I need to clarify. So today we're going to continue talking about simplifying radical expressions, but we're going to move on and talk about the relationship between radicals and exponents. So before I move on to the new material, I just wanted to clarify a couple things that I saw in the work that those of you that handed in the worksheet, like I said, you gave me some good insight. So just a quick review. So this first problem, we're going to take the fourth root of 162. So we're going to break this down using a tree. So we're going to do 2 and 81, 9 and 9, 3 and 3, 3 and 3. Okay, and the index here, we're taking the fourth root, so we're looking for 4 of a kind. So we have 3 4s here, so we're going to put 3 out in front. And then one thing I saw a lot of is a couple of you are not putting that index back where it belongs. Okay, so our leftover number is 2. We have to put the 2 back under the fourth root. Okay, if you don't put the 4 there, then you're implying that this is a square root, and it's not a square root problem. Okay, the next problem, I want to talk about how do we handle this negative. So you can take the cubed root of a negative, okay, and the first thing you're going to do is you're going to break this down, just break down positive 500. We'll worry about the negative at the end. So we've got 5 and 100, and then we can do 10 and 10, and then 5 and 2, 5 and 2, and we're taking the cubed root, so we're looking for 3 of a kind. So notice that we have 3 5s. What we're going to do is we're going to make all of those 5s negative. Okay, when we multiply negative 5 by itself 3 times, that answer is going to be negative. Okay, so we're going to take a negative 5 out, and then the numbers that are left over, we've got a 2 here, and we've got another 2 here, so we're going to multiply those. We're going to put them back under the cubed root, and we're going to put a 4. Okay, and so our answer is negative 5 times the cubed root of 4. So if you are taking an odd root of a negative, the number that comes out will be negative, so your answer will be negative. Okay, and then in the last example here, we're taking the fifth root of 128. So I'm going to break that up using 2 and 64, and then I'm going to do 8 and 8, 2 and 4. A couple of you didn't break down your 4s. Okay, 4 is not a prime number. You got to break that down into a pair of 2s. Okay, so if we want to take the fifth root, we got to look at all of the numbers on the bottom of our branches. We've got 2, 2, 2, 2, 2, 2, 2, 2. So we've got 7 2s. We need to circle 5 of them. 1, 2, 3, 4, 5. Okay, so we take a 2 out. We have to put a 5 in the nook. We're left with 2 2s. We're going to multiply those and put a 4 underneath the root. Okay, so our answer is 2 times the fifth root of 4. Okay, so now we're going to go ahead and move on, and we're going to talk about the relationship between radicals and exponents. So when you take a square root or a cubed root of a number, that can actually be represented in exponential form. Okay, and when you change a radical to an exponent, we call the new form rational exponent form. Remember, the word rational means a fraction. Okay, so if I want to change the nth root of a to an exponent, we're going to use that radicand as our base. This number called the index is going to become the denominator of your fraction. And if you don't see any numbers on the outside, we're just going to put a 1 on top. Okay, so the nth root of a can be written as a to the 1 over n power. Okay, so to try to clarify that, if I have the square root of 25, okay, remember there's an invisible 2 right here in the nook. And so I can write this, I'm going to think of this as just, this is being raised to the first power. So I can rewrite this as 25 to the 1/2 power. And if you type the square root of 25 in your calculator, you'll get 5. And if you type 25 to the 1/2 power in your calculator, you will also get 5. Okay, so I'm actually going to skip this next part over here, and I'm just going to do example 1 with you to try and kind of explain what we just talked about. So example 1, rewrite the given expression using radicals and then simplify. okay? So we're going to take this rational exponent form and we're going to write it as a radical, and then we're going to simplify it using what we talked about yesterday. So I'm going to put a radical, I'm going to take the base of the exponent, and I'm going to put that underneath my radical sign. And then this denominator becomes what we call the index. That's the number that goes in the nook. And then if the numerator is 1, you're done. Okay, we don't have to, you can think of this as raising this to the 1 power, but it's not going to affect anything. So 27 to the 1/3 power, we can simplify the cubed root of 27. So we can do 3 and 9, 3 and 3. We're looking for a set of 3, so we have 3 3s, and so the cubed root of 27 is 3. Okay, so 36 to the 1/2. If you understand that that is the same as the square root of 36, so the 2 goes in the nook. Okay, and when that's a 2, it's the same as the square root. And the square root of 36, we probably don't even need a tree. If we use a tree, we'll probably just go right to 6 and 6. Square root of 36 is 6. Okay, and the last example, if we have 16 to the 1/4 power, that denominator becomes the index, so we write the 4th power of 16. That top number is a 1, so it's just the 4th power of 16, 4th root of 16, I'm sorry. And then we can do 4 and 4, 2 and 2, 2 and 2. And so we have a set of 4 2s, and so our answer is 2. And notice in each of these examples we did not have any numbers left, so these were all perfect roots. Okay? Now, in the next set of examples, what you're going to notice is that there's going to be a number, okay, when we rewrite. So what we just did is we actually went backwards here. We wrote our rational exponent as a radical. Okay, so what you're going to notice in the next set of problems is that when we write our radical, we're going to have an exponent here on the outside. Okay, so if your rational exponent form looks like this, okay, a to the m over n power. Okay, notice n, the index is the denominator, but now the numerator is something other than a 1. So if you see a number right here, okay, that's going to go, these two numbers go together. Okay, and again, that will make more sense when we look at an example. All right, so let's take a look at a couple more problems. Okay, so we're going to rewrite in radical form, and then we're going to simplify. So I'm going to start by making a radical. I'm going to put my 4 here. The denominator goes in the nook, and then I'm going to take this whole thing and raise it to the 3rd power. Okay, so now I'm going to take the square root of 4. The square root of 4 is 2, and then I'm going to raise that to the 3rd power. Okay, you can use a calculator. 2 times 2 times 2 is 8. So you take the root first, and then you're going to raise it to the power. So for the next one, we're going to write this as the cubed root of 27. And then we're going to take that answer and we're going to square it. So again, the bottom number, the denominator, becomes the index, and the top number becomes the exponent. And then you're going to work from the inside out. Okay, so the cubed root of 27, I think some of you know by now that one is 3. And then we're going to take 3 and we're going to square it, and so the answer is 9. Okay, and then lastly, we have 16 to the 3/4 power. So this time we're going to do the 4th root of 16. We're going to take our answer and we're going to raise that to the 3rd power. Okay, so for 16, if you're not familiar with the 4th root of 16, we can break it down 4 and 4, 2 and 2, 2 and 2. Okay, and so this is going to equal 2, and then we're going to raise that to the 3rd power. 2 times 2 times 2 equals 8. So now we've got 2 steps. We're going to take the root, and then we're going to raise it to the power. Okay, and then in the last set of examples, okay, you're going to notice that our answer is not going to be a whole number. We're going to have to simplify our radical. Okay, so 24 to the 1/2 power. So it says rewrite in using radicals and then simplify. So I'm going to write this as the square root of 24. Okay, that 2, you can put it there or it can be left as invisible. Okay, now I can't take the square root of 24 and get a whole number, so I'm going to do 4 and 6, 2 and 2, 2, and 3. I'm looking for 2 of a kind, so I take 2 out. I'm left with 2 and 3. I'm going to multiply those and put a 6. Okay, and because it's a square root, I don't have to put the 2 back in the nook. If you want to, you can go ahead and put a 2 there. Okay, so the next one, we have the cubed root of 16. Okay, so we're going to break this down doing 4 and 4, 2 and 2, 2 and 2. We have a set of 3 2's here. So we take a 2 out, and then we're left with the cubed root of 2. And remember to put that 3 right back there. Okay, so we're just adding in that first step of writing it in radical form and then simplifying it. So this last one, we have the cubed root of negative 48. Okay, so we're going to go ahead and break the 48 down. I'm going to do 3 and 16, 4 and 4, 2 and 2, 2 and 2. And remember, because that 48 is negative, we're going to look for 3 2's. I have 3 of them right here, and I'm going to make all of those negative. So I'm going to take out a negative 2, and then I'm going to multiply the 3 and the 2 that are left, and I get the cubed root of 6. Oh, I think my iPad just got frozen. Let me restart that. Okay, sorry for the delay there. Okay, so, and that was the negative 2 cubed root of 6. Okay, so I'd like you to pause the video and go ahead and try these last 3 problems and then check your answers. Just kind of fast forward to the end. Okay, I'm going to just kind of work through them, but try them on your own first. So this is going to be the cubed root of 81. So we can do 9 and 9, 3 and 3, 3 and 3. Okay, so we need 3 of a kind, so we take a 3 out, and we're left with the cubed root of 3. Okay, and then the next one, you've got the cubed root of negative 27, and then you're going to take that answer and square it. Okay, so the cubed root of negative 27 is negative 3. Okay, and then we're going to square that, and when you square a negative, you get a positive, and so the answer is positive 9. Negative 3 times negative 3. And the last one, you're going to take the square root of 16, that 2 means square root, and we're going to cube it, and so the square root of 16 is 4, and then you can use a calculator if you need to. 4 times 4 is 16. 16 times 4 is 64. Okay, so I'm not going to give you additional homework tonight. I'm going to give you a practice sheet to do tomorrow, which will be on Wednesday. So your only homework tonight is to work on your 60, or I'm sorry, not even tonight, I guess today. The rest of your math time should be spent doing some ALEKS. I will be in touch via Schoology, and I will make another video probably again on Thursday. Hope you're doing